Last class, we talked a little bit about CN, right? Use CN to get something from the user, right? Some input. And I said, right now, right, you can't really limit what the user is going to give you, right? But I also said what? Don't what the user? Don't trust the user, right? Never trust the user to give you what it is that you're asking for. And so we're gonna look at something called CN Reader today, which will limit users' input to be what I want. If I want an integer, they'll only be able to give me an integer. If I want an integer between two numbers, like in the number guessing game, right? An integer between 1 and 10. CN Reader is going to allow me to get a number between 1 and 10. All right, so it's pretty nice what it can do. When we're done talking about that, we're going to talk about code style. Code style is basically what our code looks like. So not syntactically like where's the semicolon and how it's ordered, but kind of where's my white space and that kind of stuff. So we'll do code style. And then we're going to start talking about Boolean expressions. Remember, expressions are like variables, symbols, literals all put together that become a literal value, right? X plus 2, right, becomes some value. That's an expression. Now, Boolean expressions are expressions that evaluate to Booleans, which means that they evaluate to what? True or false, right? And true or false are kind of going to be the basis of all decisions computers make. And so we'll look at Boolean expressions today. Then on Tuesday of next week, right? Today's Thursday. Someone help me out? Yeah?
Yeah.
Okay, good.
Pretty sure.
So on Tuesday of next week, we'll look at where we use those Boolean expressions to actually do branching in our code and go different. Make sense? Anyone have questions about that? All right, cool. So let's talk about CN Reader. All right, so kind of already set this up, right? Sometimes people give us the wrong thing. Right here, int num creates me a what? An integer variable of type int, because he just said integer variable, right? Like, no, of course it's of type int. Right? Are we good with that? And its name is num. Right? I just keep revisiting this because, well, it's important, right? It becomes second nature. To create variables should become second nature to you, right? Create a variable and then you can store stuff in it, right? This line of code, which we learned last class, says get from the user, right? Console input, get from the user and store it where?
In num.
In num, good. Right? And so, of course, the user's going to type a number, right? Hopefully. Right? But probably not. Right? So the user inputs what?
Capital Y.
Capital Y. Is Y a number?
No.
No, and in fact, they just broke your program. Your program will not accept any more input from the user. That sounds terrible, right? It won't. Not with the way it works. You don't look at it as a canister, not as like the ASCII program. All right, so everybody that is a problem. So to fix this problem, we're going to use something, and that something we're going to use is called CN Reader, created by one of the other faculty that we have. And so I'll show you how to bring those files into your program and kind of use what they do.
It's a badass.
So CN Reader is a library created. But yeah, by Boyd. One of the other teachers. So you create the library and it's just an input handler. Brings everything in, make sure that you get what you want to get. There are two files associated with CN Reader, and today I'll show you where they are on Cloud 9. CNReader.cpp, that's kind of where all the code is, most of the code, and CNReader.h. It's a header file. It has just a little bit of code and a lot of comments. Okay, you need both of those files in the same directory as your main file in order to use CN Reader. So you'll have CN Reader file, two of them, right, and your main file, all three together, make up your program. This is the first time where we're having multiple files make up a single program, right? So far it's been one file with main in it. And now we have three files that we're going to bring together. I'm going to teach you today how to do that. Once you do that, you have to add and include in your main file to say I'm using the code from this other file. Right? Normally we include like IOStream or string, that kind of stuff with the alligator jaws. And here you notice that I'm including not with alligator jaws, but with what? Well, double quotes, because it's a file. Okay, when you're including a file in the same directory, you use double quotes. All right, and then in main, it's almost like you create a variable. All right, CN Reader becomes your new type, and then in this case, Reader becomes your variable. It's a super special variable. We call it an instance of CN Reader. All right, which means, do I have to call it Reader? No, I can call it anything, right? That is an identifier, but all my slides all of my examples will always call it reader.
That makes sense to call it reader.
Yeah. Read from user, I mean, I don't know. Call it something that makes sense. And then C and reader, though, it has to be that. That's the type. Just like int, double, char, string, and bool are types. Now C and reader is a type as well. And soon, after our first test, we're going to learn how to make our own types as well. Okay, good with this? I'll show you, right? We'll do it in an example so you'll see where all this code goes, right? This goes up with the includes, right? So above main, right? This code here actually goes in main. And so we'll see how it's all divided up. And so after that, basically we have 5 ways of getting, right, values from the user. We can read integers, we can read doubles, we can read booleans, chars, and strings. So I'll just show you how all 5 of those work, and then we'll be good to go. Questions so far? Does this make a little bit of sense?
Is there space after the R?
Right here?
Include.h.
No spaces. Yeah, it kind of looks like there's a space there, huh? No space. All together. All right, let's look at the first one. Read int. Read int's going to get what from the user?
Sure.
An integer. Go figure, right? Nicely named.
Hopefully.
Hopefully, right? So, for example, I create a variable that is called int_var, right? And in lieu of saying cn 2 greater than symbols int_var, right? That's how we used to do it. We used to say cn 2 greater than symbols int_var, okay? But that allowed the user to type whatever they wanted, agreed? Right? So we don't do that. In fact, we don't do cn 2 greater than symbols anymore when you use cn reader, okay? Instead, you say int_var gets assigned, right? Because 1 equal sign is assignment, right? Int_var gets assigned reader.readInt. Reader.readInt will do all the work to go out to the user, grab an integer, make sure it's an integer, get that value, and bring it back. Once it brings it back, what's it going to do with it? It's going to assign it to int. Does that make sense? Reader.readInt gets a value. This line right here becomes an integer. What do you do with an integer? Store. So don't just say reader.readInt, right? Say reader.readInt gets assigned to something. It needs to go something.
It's kind of like having like a prototype.
Where's reader.readInt coming from? Well, it's going somewhere else in those files, right? Those C and reader files. It's going in there, which has its own CN statement.
Okay,
but it's all being handled behind the scenes.
You'll have to declare that it's in the file where you store it again.
Yeah, exactly. Once I did this, C and reader, now I have access to reader, and I can say reader.all these things.
So it's kind of like that include is like your prototype, and these are all like news off of it.
Yeah. You can also tell the range of numbers, so you can say reader.readInt, and in the parens, you can say lower limit, comma, upper limit. Right? This would have been very useful for your number guessing game, right?
Also, they can't type in 23.
They can't type in 23. It's an integer, but it's not within the range of values that we want it to be.
I have another question on that though. So
Yeah.
if they typed in 23, would it then just retain the 3, the last?
No, it will. We'll see examples of it. It's going to force the user to type something in. So if they type the wrong thing in, it's going to prompt them again.
That's kind of rare.
So it's going to loop for forever until they give you something else. Okay. It's an inclusive range. So 1, 10 means 1 to 10, including 1 and 10, right? Include the elements. Read double gets a what? A double. Go figure, right?
Can you use exclude?
No. Just include, yeah. So here we have a double var. Double var gets assigned reader.read double. Right, notice it's always the same. Some variable gets assigned reader.read and then whatever type I'm trying to read. In this case, I'm reading a double. What can the user type in? A double. Technically, the user can type in an integer. It'll work as well, right? If they type in 5, it'll get converted to 5.0. So that's fine to do as well. Read double's not that exciting. You can't limit the range of numbers. Because doubles does not really make any sense to limit. Because even if you limit between 1 and 2, there's still an infinite number of numbers between 1 and 2 that they can type in.
Now, will that limit it to 5.2, or could they still, if you put in limit to, would it be just the 1 decimal, or would it
double?
be like, yeah?
Double, there is no way to limit it.
Okay, cool.
Yeah, it's just read double. They can type in any double, and really any double. So we did read double, we did read char, right? For Boolean, what do you think it's called? Read bool. Go figure, right? Read bool. Reads a Boolean from the user. Right? Here's my bool var. Bool var gets assigned reader.read bool. Hopefully you're seeing it's the same pattern. Some variable gets assigned reader.read whatever the heck I'm trying to read. Right? Booleans are true and false. And so what it's going to take for input is either a T or an F or true or false. Okay, it says case insensitive. It's insensitive about case, meaning that it could be uppercase or it could be lowercase. It doesn't
Be an adult about it.
Right, yeah, exactly, right? It's all good. I'll take upper, I'll take lower. Does that make sense? Right? Very rarely do you ever read Booleans because normal people, and I know we're not normal people because we're programmers now, but normal people normally don't like say true, false all the time. Right? They might say yes or no, right? But they normally don't do true and false.
Unless you're quoting twice.
Right?
False.
It will not take integers for true, false. So it will literally only take a T or an F or a true or false. So it's only 4 inputs that have it. All right, read bool. What's the next one? Characters. So it's called what? Read char. Go figure, right? Read char reads a single character from the user because a character holds how many characters? 1. Chars. There's my char var. Char var gets assigned reader.read char. Easy enough, right? Now this one, the user can pretty much type whatever they want, so long as they only type one thing, right? Because even if you type 5. Right? 5 can be treated as a character, agreed? Is 5 on your keyboard as a character? Yeah, right? So all the keys on your keyboard you can type in, right? So we'll take them. Something really nice about reading characters that I like is that you can limit the characters that the user can enter. You do that by putting a string of characters that are allowed. So here, char var gets assigned reader.read char, and notice I have double quotes, a string literal, right? Double quotes, string literal. Inside of it, the characters that are allowed. Case sensitive.
That's pretty cool.
Right? So the only 6 characters the user can type are what? Lowercase a through F. Good. They can't type uppercase A, they can't type 5, right? Because that's not allowed. Okay? Students a lot of times like to put commas between everything, like they do A, comma B, comma C, comma D. All that does is make it so that the user can also type a comma. Because it's a character, right? That's not what you want, right? You literally put in the quotes only the characters that you want to be allowed, because you're in a string literal. So just put the characters that you want to be allowed.
So is that because the string is actually the char?
Yeah, a little bit. Yeah.
Why would you? So okay, similar but separate question.
Yeah.
So why would you need double if you can just use char and let them do 5.0?
But you can't do 5.0 because char is only one character.
Okay.
So you can't do the 0.0.
You have to include every single. Okay.
And then if it comes in as a character, it doesn't convert over to a double. So like if it came in as a string, you can't just use a string as a double, right, to do math.
Okay.
So you really need to deal with the types that you have. I was gonna say something else. Oh yeah, so like even like for if you like want to continue, yes or no, right? A lot of times I'll do read char for that. Right? Do you want to continue? Enter Y for yes and N for no. Right? As opposed to like true, false, or typing the whole word yes or no. You'll see an example of that in a little bit. All right, so that's characters. What's the last one? String. So it's called read string, right? Get the string from a user. Yay. Right? String var gets assigned reader.read string. Right? That allows the user to type anything including spaces. They type anything including spaces and hit enter, and that will come into your program. Now strings are strings of characters from 0 to many characters. Everyone good with that? You can have 0 characters in a string and you can have many characters in a string. Which means that by default with read string, the user can just hit enter. Right? So if you ask the user, please enter your name, and you said reader.read string, right? It's not going to force the user to type anything. They could just hit enter, right? Because the empty string is an allowable thing, right? Now, if you want to force the user to type something in, you put false in the parentheses, right? It's the idea of, do you allow the empty string? False, no, I don't allow it. True, yes, I do allow it. So false says, do not allow the empty string, meaning the user must type something. At least one character, right? They might type only one, but that's okay. But they have to type at least one character. Does that make sense a little bit?
That's like say you're ordering something online and you don't have to put your house number.
Right, optional or not.
Like
right?
they were able to do that by saying true.
So this would almost be like optional and then required. You can also limit a length of characters, right? I only want 5 characters, I only want 10 characters. It's a second, what I call parameter, it's a second thing that I pass in. And so you have to say true or false. True meaning allow the empty string, false meaning not allow the empty string, comma, however many characters I want to allow. In this case, you can type as many characters as you want, but I'm only going to take how many characters? 5. I'm only going to take the first 5. You say false 5, and then they have to at least type 1. So this basically says true 5 says 0 to 5 characters, false 5 says 1 to 5 characters. So that could be true or false. All right, you want to see some examples?
Yeah,
Let's do it. So let's see. I just kind of want to show you how it's set up. Inside of today's lecture, lecture 5, I have cnreader.cpp and cnreader.h and cnreader example, right? All 3 files in the same folder with no other CPP files. Okay, that's something that we have to do for Cloud 9, right? This is one place to get your cnreader files. Another place is you have a folder on the root of the directories that's called cnreader, and guess what's in those? The cnreader files, right?
No way.
So there are a couple different places. Crazy. They're also already in your assignments 2 folder because you're going to have to use cnreader for assignments 2. What was I going to say? Yeah, that's all I was going to say. Okay. Now, in my cnreader example file, which is in the same directory as cnreader.cpp and cnreader.h, line 11, I include, so after my other includes, I just include in double quotes cnreader.h. Case sensitive, right? Capital C, capital R. Make sense? Everyone kind of good there? Questions about that? Cool. Right, then in main, the first thing I need to do is actually create what we call our instance of cnreader. We have to create the variable that is the reader. Okay, we do that by just saying cnreader, right? That's my type, and then I just give it a name. And so I'm just going to call it reader. Everyone good so far? All right. Let's set it up. Int var. Right, what a great name for a variable. We always do great variable. Right? Cout, please enter a value. I'm keeping it generic because I don't want to keep typing over and over again. Normally you would like ask the user for what you're really looking for. Right? And before we used to do cn 2 greater than symbols var, right? Are we good with that? And now we say var gets assigned reader dot something. In this case, we'll do readInt. Right, and then we'll just see out the value entered was this. All right, type would be good. Line 20, create a variable to hold integers, ask the user for a value. That variable will get assigned an integer, right? If you say reader.readInt, paren, right, open paren, close paren, right, you will get an integer before your program continues. Right, that's the promise that I'm making you. You will get an integer before the program continues on. Make sense? Everyone good with that? Should we see if it works?
Sure.
Why not? Why not? Run it.
Yeah, he went to the next line.
Right? Did it work?
No?
Nope.
No, right? Can anyone see what the error message says? Undefined reference to cnreader. Everyone see that? Undefined reference to cnreader?
Yeah.
But I included it, didn't I?
Yeah, but you didn't include the
You have to
directory.
create the variables you'll be using beforehand.
But I did, right? I created the variable here. I created, so everything's created, but when you compile, C++ needs to know all the files that it needs to compile. And by default in Cloud 9, it doesn't do that. It only compiles your one file. But now how many files do I have? 3, right? Mm-hmm. And so what I've done and given you, although you don't have it yet, you'll have it by the end of today. All right? Under runners, right, there's a list of how you compile it. it's been compiling C++ simple. And after you do some magic today that I'm going to teach you, you'll have C++ assignments. Okay? Exactly, right? It's always magic. We do a lot of magic in this class. So C++ assignments allows you to compile all of the files. So notice, did I change my code at all?
Nope.
No, but I did change the way that it's compiling. And now when I hit run, right, what does it say?
Please enter
Please
value.
enter value. So did it compile? Yeah. Is H an integer?
Sure.
No, H is not an integer.
Yeah, I know that.
Right? Is 3.1 an integer?
Nope.
True?
No.
Foobar?
Oh.
Right? Everybody see? Until I give an integer, my program what? Will not continue, right?
Re-enter.
Alright, so just keep re-entering. But is 10 an integer?
Yes.
So I type 10, I hit enter, and right, the value entered was what?
10.
10. Readint will require the user to add an integer.
Would it be possible to have multiple error messages for the exact same thing, or do you need like different ones? So if the user types in a word, then it's like, please render it as a number with italicized or something.
It doesn't do that by default. You can, if you read the H file, which has all the documentation for it, there is a way to change what the error messages are.
Oh, so we can't compile ours because we need to do that trick you
Yeah.
just did? I was like, wait, C.H is screwed.
Yeah, it's there. But you can't, yeah, you'll be able to compile yours.
If I dragged my CPP I made into lecture 5, will it run then?
No.
Dang it.
Yeah.
I was trying to be
You
tricky.
need something special. I will give you, but not yet. Remember, you can also limit it with a range, right? So if I said 1, 10,
And it'll include those numbers.
including those numbers, right? So it still won't take like hello, right? That doesn't work.
Help.
But it also won't take 0. Won't take hell either, right? It won't take 0. Won't take 11,
Hell is
but it will
range.
take 1, right? So pretty useful, right? You can limit the range of values the user can give you. So let's read in, right? I'm going to change int var to be double var.
Cool.
Right. Now you see why I did it so generically, right? And now instead of read integers, what am I going to read?
Read double.
Read double. There you go. And what's this going to read?
Double.
Double, right? So I can't just hit enter. That doesn't work.
Re-enter.
Right? I can't say hello. That doesn't work. Can I say 5?
No.
Some say no. Some say yes. Right?
Oh.
It's okay. It will take integers. Read double will take integers and just convert. But it also will take, double. Right? So I can do. Apparently, we really like pie in this class. I made you do it
It's
like
delicious.
Class, right? And there it goes. I actually hate pie. I don't know why. Hate's probably too strong a word, but it would probably be my least favorite dessert.
I could probably die in a fire for it.
It'd be okay there. Make sense?
I
Everyone
like
with
nothing
this?
with
What's the
a
next
pie.
one? Read double, then what?
Read care.
Before read care, let's do read bool. Right? Read double and read bool are the two that don't have anything in the parentheses. They'll never have anything in the parentheses. Right? So enter a value. I try to do 1. Sorry. And this error message says, please enter what?
True or false.
But you can't just do like true without the E.
True.
Right? It is case insensitive though, so I could do, right, a weird true like that. Right. Value enter was 1. Why does it say 1 and not true?
Because 1 means true. And,
One means true, right? On output, see out outputs booleans as 1 for true and 0 for false.
Yeah.
That is true. We're gonna do a lot with true and false today, which will be kind of fun.
No.
Right? So you can type the whole thing, or you can just do F. Right? You don't have to type false. You just do it false.
Yeah.
That integer was what?
0.
All right. Cares. Care bears. Reader.read care. And pretty much you can write anything, type anything so long as it's only 1 character, right? Hidden enter will not work. 2 characters does not work. But a tilde, right, it does work. Right? Any character you can type, read care is going to pull in that character. Right? And var will be that value, right? So var was the tilde, right? So when I see out in var, what did I see? Saw the tilde. Remember, chars, you can limit the characters for the user, right? So in double quotes, I can do like A, Z, Z. Okay, that doesn't mean A through Z. Sometimes students try to do this too. They're like, sweet, let's just do, right, all A's through Z's. Right? What does that really say? The user can type what?
A and Z.
Capital A, lowercase a, capital Z, lowercase z, and a what?
Hyphen.
And a dash, right? Remember, you put the allowed characters in there, which means if you want the user to be able to type all upper and lowercase letters, you have to type 26 times 2, 52 right
Different
characters.
way to do that though.
No other way to do it. Not for us.
Dear Lord.
Oh, great.
Except for using a string, yeah. And then I'll take in whatever. But then you can't limit. Strings you can't limit. So if you want to limit what the user types, right? With this method, you would have to do AA, BB, CC, DD, ED, FF. That's a lot. Hopefully you don't need that.
Nope.
Right? Because then basically you're saying like there's 26 options the user can type in, which I don't know what you're building, but that's a lot of options. All right. So let's look at this, AAZZ. All right. I still can't like type 2 letters, that's not allowed. But now I also can't type numbers, those aren't allowed. Right? I can't do B, that's not allowed. But your uppercase Z, is that allowed? Yep. Heck yeah. All right, so it's all good. Make sense? Everyone kind of good with this? Read int, read double, read bool, read char, and read
String.
string. So let's do string. So here we'll do read string, open, close paren, don't forget your parens. What can I type now?
You can press enter.
I can press enter and pretty much I can type whatever I want, right? Because whatever I want will just be interpreted as a character. But I just hit enter. So exciting.
Value
You
entered
can
was
say
nothing.
false and they can't do that.
Right. So we're gonna get there in a second. But I also wanted to show that you can do like spaces. Apparently
Please enter a value, Luke.
yeah, here we go. Let's try this again. I want to see there's a space there. Right. I don't know if I showed this class, but using CN, you can't like get strings with a space because we separate our input with spaces. But this will allow us to get spaces. So that works. We don't want the user to be able to just hit enter. What do we put in the parens?
False.
False. Run that. And now that forces the user, right? Input cannot be blank. Right? But I can type, right, literally whatever I want. Would that work?
Look, the launch codes.
It's a great string. Right? Now you need to decode it and figure out what my secret message is.
It's the launch codes, that's what those are.
Yeah, right? For what?
For something.
Something. All right. I can also add in a comma and like put in a 5. That says, do not allow the empty string, so the user has to type in at least 1 character, but I will only take up to how many characters?
5.
Okay. Now, do you realize that when I say it will only take up to that many characters, the user can still type as many characters as they want. Okay, but it will only take how many characters? The first 5. Okay. So it's not going to stop them from typing as long as they want, right? But it will only take the first 5.
That's how like Twitter limits your.
Okay, type as much as you want, and they're like, sorry, this is my limit.
Word limits.
Didn't they just up the limit for special people? Anyone read that article?
Yeah.
If you have enough followers, then you can type more. Because you have more to say, apparently. Questions? CN Reader is useful. It is. Oh, go for it.
Do you have larger arrays, or is it just those 2?
Just those. So yeah, just those 2 options. What was I gonna say? CN Reader will be required for all your assignments. So you have like 4 more assignments-ish this semester. You'll have to use them for that, right? Because if you make a program, we want to assume that the input we get is correct, and to make sure the input's correct, we use CN Reader. Does that make sense? But like for labs, besides like today's lab where you actually have to practice it, right? Just use CN, right? Because if you want to use CN Reader, you got to go through the steps of including the file and creating the instance and bringing all the files together on the file system, right? For labs, right? You're the one who's doing the input, so I don't really care. All right. So for labs, you can just use plain old CN if you want, right? But for all your assignments, you'll use CN.
Are you showing us how to do that including thing today or no?
Yes. How do I get the thing?
Yeah.
Yeah, I'll show you how to get it.
Because I want to.
We will get there.
So for everybody else in the world using C++, does not know about this particular library written by somebody.
Then they write their own.
Wow.
This is why I'm gonna keep this.
The key is, if you want to write an input handler, the best way to write it is to take everything as a string, because strings are valid, and then you can test the strings to see what's in them, and then try to convert them over. All right, you guys ready for something totally different? All right, we're talking about code style. All right, let's talk about code style. Right, code style is basically how your code looks. So not like where your semicolons are, right? I said that, not like how, right, how the lines are lined up perfectly, but really the fact that our includes come first, and then main, we have an open curly, and then inside of that, things are indented over, right? We don't write things too long, right? So it encompasses kind of everything that we write, right? The goal is for all of us to be consistent, all right? So we're all going to write to the same code style, so all of our code should look stylistically about the same. Helps us read our own code, right? Helps us read other people's code. It really helps you find mistakes too, because if you indented everything correctly, then you'll figure out where you missed your curly brace and that kind of stuff. So it will help you out. And it makes your code really easier to read and modify because you can kind of see where everything is. And if you go into actual programming at some programming company, right, they will have a style guide that you will follow. Right? You won't be able to go in and be like, well, you do it this way, but I'm going to do it my own way. I'll be like, this is how we do it. You write how I want you to write your code. Or you find a new job, which you would do that. So in this class, you'll follow my style, even if you don't like it. And then if you take the next class, right, you'll follow whatever style is in that class. So it's good to be agile in changing your styles. They don't normally look that much different, but a little bit. So let's look at some of the things that we do. One of the big things we do with style is to write comments. Comments are used to describe our code. For us, our comments usually are like mostly our pseudocode, right? They're describing what the code is actually doing. All right, we use 2 forward slashes to do single line comments, and a /* to open multi-line comments, and a */ to end multi-line comments. Right, so the top of all my examples, it should be at the top of all of your code and assignments, is a comment block. It starts with a /*, ends with a */, and it has like your name, file name, right, description of what your program is. Then later on, there should be comments, single line comments that explain what your code is doing, mostly relating to your pseudocode.
Can you block comments when you go?
You can. You can have block comments, and when we start writing these things called functions, we'll start writing block comments. You don't need to comment every single line of code. All right, we comment blocks of code, so things inside curly braces to describe what's happening. When something's important or something doesn't like make a lot of sense, like you did something special that other people might not pick up on, right? That's when you want to write comments. So there's not really like a rule of thumb. It's not every line. It's not like once, every five lines, make sure that you have a comment, right? So we'll start kind of learning a little bit how often we have comments. But really, right, as you describe what your program's doing, that's where your comments come. Overall, we're stealing from Google C++ style guide, which you could read if you're really bored late at night, but I probably wouldn't.
I'm not gonna be that bored.
Has lots of rules for things like indentation and spacing and how we name variables, how we name constants, all that kind of stuff. So we'll just go through all these things on the next slides. Indentation, blocks of code are always indented. Blocks of codes are things that start with an opening curly brace and end in a closing curly brace. Right? So those are blocks of code, right? Like main. Int, main, open, close paren, and then what? Opening curly. And then a closing curly at the bottom, right? And inside of there, you'll notice that all my examples, the code has been what? Indented over. Okay, so I indent 2 spaces, right? Don't use tabs. I don't like tabs. They don't like tabs. So we indent over 2 spaces. Now I'll show you on Cloud 9 how you can make it so that when you hit the tab key, it gives you 2 spaces. So I hit the tab key all the time, but it doesn't add tabs. It adds spaces. Yes?
I cn_reader.cpp occurs to use full tabs.
Yeah, that's not because I didn't write it. Not my code.
Voids.
Void's code. I didn't update it. That's how it is. It also has camel case for its name, which I don't do either. That's not mine. So, right? And that'll happen too. You bring in external libraries, and this library will have this style of code, and this library will have this style.
April and Blake.
Yeah, they do, but I do. Curly braces here, right? April uses camel case because JavaScript usually by convention is camel case. So here's main. Everything inside of main, because it's a block of code, is indented over 2 spaces.
Everything inside or the versus the last bracket?
The last bracket is not, because the last bracket closes the opening bracket, so it lines up with what it's closing. But everything else will be indented over 2. Now, if you have a block of code inside of a block of code, everything inside of that block of code is indented over how many spaces? Or two, because you're already indented over 2, and then 2 more because you're right. So we're talking about things like, right? I have this, and I have some code here and some code here, and then I have this, and so the next code is indented over as well. This lines up to close that, and this lines up to close that. Does that make sense? I had a former student, she called them drunken seagulls. My curly braces are terrible.
Do you know how? So okay, when you're writing code and you're indenting things, a lot of the programs I've used to do like the dotted lines show kind of like that's where that's from. So you're not you're doing a multi-billion if statement.
So Cloud9 will do that too. You can fold the code. It also will put a line between like where your indentation is.
If you're indenting and you're not getting them, how do you make them come up?
I don't know. I thought Cloud9 did it by default.
Yeah,
Yeah.
Because there's times where I'm like I'm not getting it.
Normally, if you're not getting it, it's because you like something screwed up. Like maybe you missed that or something.
Because like when you know how you gave us an example if for our last assignment, so I had to kind of just like block comment out the whole thing and write the if again because I could not find where all the curlies ended so that I could make my extra else's.
Yeah, it should line up. It should do that little line that lines up. You should be able to fold them like with a little carrot and it'll fold up.
They just weren't coming out, so I was like, crap.
Yeah. Normally, like I said, normally it won't do that if you have a syntax.
Okay.
It's actually reading your syntax and kind of basing on that. All right, there's my indentation. What else we got? White space is important, right? I like a space after my paren. So like if this was int main, be int main, open, close paren, space, and then a curly, right? So that space between the closing paren and the opening curly. But don't put spaces after, right, before semicolons. That's just a little weird. So don't do that. Don't worry about that. Naming I'm going to breeze through because we've already talked a lot about how we name our variables, right? Give good names. Right, so I'm just gonna kind of breeze through these because we've been doing it, right? But things like n doesn't mean anything, n error, once again, doesn't really mean anything. Name them, right, what they are, so it makes sense, right? It helps document what your code is. File name should be lowercase underscores between words, much like we name variables, right? Notice our program's always end in .cpp, right? You don't end in .cpp, your program's not gonna compile. So make sure you end that. And we saw constants, right? Start with a K and then it's mixed case, right? So constants for K and then days in a week, mixed case, right? Uppercase for each succeeding word. Right, so constants look a lot different than our variables, right? Which is just a visual clue for us of what's going on. Make sense? Variables we saw all lowercase, underscores between words. I've heard it called snake case before. Right, so we have this thing where all of our words are separated by underscores. Line length, I think we talked about this. Line length is set at 80, and in Cloud9 there is a line, right? So the goal is not to go over that line, right? That's like the cliff. We'll go over the cliff. If you write a line that's long, you're gonna have to pull some of the line down to the next line, and then try to like line it up so it goes nice. Spaces versus tabs. What are we gonna use?
2 spaces.
Good. And then when you do a return statement, you don't return doesn't need parentheses. And you'll see some people like do that in their code, but you don't need it. So don't do it. Right? Like return 0, like the end of main return 0. Sometimes people have parentheses which don't actually do anything. You can have parentheses all over the place that don't do anything. You can put semicolons all over the place that don't do anything.
Can you tell us to put parentheses around everything just to do it?
I said put parentheses when you're like working with mathematical expressions. Let's see. Looking at our example, right? Here's my block of code, right? And everything's indented over how many? 2. If I bring this up, you'll see that here, this is in real small letters, it says spaces, and then a colon, and then next to it will tell you how many spaces that you're dealing with. Mine says 2, so if yours doesn't say 2, it's a good idea to change it to 2. If you click on it, you can set your tab size. So I set it to 2, and then the big thing is that you want soft tabs checked. Soft tabs means when you hit the tab button, you don't get a tab, you get 2 spaces. Or 4, or 8, which would be really weird.
8.
Make sense a little bit? Right. Otherwise, I don't know what else to say here. Okay. Opening comment block at the top. Oh, there's one other thing I was going to teach you. Okay. If you're on any line of code and you want to just comment it out, so comments are great for us to explain what our code's doing. Comments are also great to be like, I'm not so sure if I want this code or not, so let me just get rid of it temporarily. But you don't want to delete it because maybe you're going to bring it back. So a lot of times we'll comment out code for that, which would be as easy as putting 2, right, / slashes at the front. Are we good with that? Now in Cloud 9, if you're on the line anywhere, you hold down Control and do / and it will comment it out for you.
That's dope.
Right, so it'll just kind of switch it back around. If I hold down Shift and like highlight multiple lines, Control / will highlight.
Yes,
Comment
that's
out.
my new best friend.
Right. If you do Control Shift / then you get multi-line comments, but it will literally put it around what you highlighted. So, Control / is really nice.
And Control / is what I imagine I Alt or something.
Are you on a Mac?
No.
No, just Control /
I'm trying to go.
Right. We'll look at it. What is the default key binding Control / All right, cool. Questions? All right. One we're going to talk about, all right, which is kind of a big key concept. So we're going to practice it in today's lab. We're going to practice it in Tuesday's lab because these things called Boolean expressions basically form the basis of our programs, right? Variables form the basis, but all decisions that we make in our program are based off of Boolean expressions, so we need to get really good at them. And so let's look at it. So Boolean expressions overall are easy, right? Something that evaluates to either true or to false, right? You want your test to be made up of Boolean expressions because you have a 50-50 chance of getting it right. Right?
Yep. Sure.
Sure, why not? Right? Although I always hated true-false questions on tests. I always did bad at them. I don't know why. Right, so Boolean expressions evaluate to true or false, which means that we have to do some kind of comparison to see if that comparison is true or that comparison is false. So I'll show you kind of all of our comparison operators symbols that do things, right? Right? So 1 greater than 5, that is a Boolean expression. We're evaluating that expression, is 1 greater than 5? And your answer is? No, which is false, right? So this Boolean expression evaluates to false. It's a fancy way of writing false, right? You could say bool x gets assigned 1 greater than 5, and x would be false. And it would always be false, because 1 is never bigger than 5. So you would never write that, but you would write something like this: cost less than value. Right? What does this evaluate to?
Cost is less than value.
No, it's not stating that. It's asking the question: is cost less than value? And the answer is depends on the value of what? Cost and value, right? And so this statement will sometimes be true and sometimes be false. And so based on those values, which are kind of unknown at this point, right, our program might go down one path or might go down another path. That make sense? Right, see here, cost greater than 5. Right, we don't know the answer until we know the value of cost. Right, so if cost is 10, Is 10 bigger than 5? Yeah, so that evaluates to true. Right? But if cost is 1, that evaluates to false. Does that make sense a little bit? Right? So Boolean expressions always evaluate to true or false. We compare what's on both sides of the operators, which will tell us if it's true or if it's false. Replacing variable names, right, with values at the appropriate. All right, let's look at the comparison operators. Okay, we're going to look at equality. Right, in math it's an equal sign, right? Equality in math is an equal sign, but in code it's a what? It's a double equal sign because one equal sign is a assignment, right? So 2 equal signs in C++ is 1 equal sign. That denotes that things are equal, right? Exclamation point equal is inequality, not equal, right? Because last time I checked this symbol, right, not on your keyboard, right? So we say not equals. So for example, Ryan, they're getting a little bit more complex now, our Boolean expressions, right? Take x plus 7, that result, and compare it to 2 times y. If they are equal, then evaluates to what? True. True, and if they're false, then evaluates, or yeah, if they're not equal, evaluates to false. So if x is 3 and y is 5, 3 plus 7 is?
10.
2 times 5 is? Does 10 equal 10? So it evaluates to? True, right? If x is 1 and y is 1, right? 1 plus 7 is 8, 2 times 1 is 2. Are they equal? False. Does that make sense, right? You're testing to see, are both sides of the comparison operator, right, equal? And if they are, then the whole thing evaluates to true. Right, because it's a Boolean expression. We'll evaluate to true or false. Answer doesn't equal 5, which is true as long as answer isn't what? Anything but 5, right? If it is 5, 5 doesn't equal 5, evaluates to false, right? But 4 doesn't equal 5, evaluates to true. Try to avoid not, right, not equal as much as you can, okay? We normally get tripped up when we start doing things from like not this and not this and not this and not this, right? Exactly. You need to switch your thinking around and try to think how you can think. You want to think positively, not negatively. Make sense a little bit? So those are equality ones. We also have less than or equal, right? So less than or equal, right? So you write it how you say it. Less than symbol or equal, so less than symbol and then an equal sign. But once again, right, the symbol is not on our keyboard. Right, so count less than n plus 3. Right, time less than equal to limit. Okay, good with this?
Yeah.
Greater than equal, same thing, except now they just go the other way. Right? Time greater than limit, age greater than or equal to 20. So we have 2 equal signs, a not equal, right? A greater than or equal, a less than or equal. So 6 comparison operators. Good? All right, so let's see if you guys are actually doing pretty good. So we're assuming int num equals 2. So I'm assuming that I have a variable called num of type what?
Integer.
Integer that stores the value of 2. All right with that? So let's see what happens. If I, in my code, or right now we're not even really dealing too much with code, but if I had num double equals 2, that values to what?
True.
True. Right? Because num is 2, does 2 equal 2? Yeah. Is 2 bigger than num?
No.
False. Because 2 is never bigger than itself. Right? Is 2 less than 2?
False.
False. Is 8 equal to num?
False.
False. Is 2 less than or equal to num? True, right? Because it's not less than, but it is equal to. Right, what about this?
True. Oh, that's.
I'm trying to trick you.
No, that way. That's undefined because it's single equals.
This is everyone good? This is assignment, not what? Not a Boolean expression for equality. Okay? This little thing is going to take hours off of your life. Hopefully just hours, but hours off of your life. Right? Because if you want to do equality, you need how many equal signs? 2. Because one equal sign means something totally different. Okay, why is it going to take years off your life? Years now, right? Hours off your life. This, if you evaluate this as a Boolean, it does work. It gives you a value. But that value becomes whatever the value is that you're assigning. So we're assigning 2. If I treat 2 as a Boolean, what do you think that's going to be? True. And it will be what? Always true, right? This here as a Boolean is always true, right? And so your branching will always go down one branch, and you'll also have changed the value of none. Probably 2 things you didn't mean to do, but you probably won't figure out why it's doing that, and then I cry a little bit. That's okay. We'll get through it. Does that make sense? Right? So really what I'm trying to say is that this right here is not a compiler error. Right? The compiler's not going to pick it up. It's logic error. Which sucks.
The scariest.
Yeah, the scariest of the scary.
You are your own enemy.
Make sense?
Yeah.
So we have a couple symbols, right? Double equal, not equal, less than or equal, greater than or greater than or equal. Just 6 symbols to do Boolean expressions. Questions on any of that? Okay, one last thing, bear with me, I know I'm talking a lot. Right? You can, just to complicate our lives, you can combine Boolean expressions together. So you can take a Boolean expression, which evaluates to true or false, and combine it with another Boolean expression, which also evaluates to what? True or false, and then you can combine them to either get true or false. Okay, so let's talk about those. All right. So we do them via either the AND operation, the OR operation, or the NOT operation. Okay. So these are called logical operators. Notice it's 2 ampersands or 2 pipes. We just learned where the pipe character was, right? Shift \, or it's an exclamation point. So those symbols, operators, allow us to combine Boolean expressions together, right? And I'm going to teach you how that combination results into either true or false. Sound good?
Setting conditions.
Because sometimes you want to do things based off of the value of 2 different things. Right? So AND is true if both sides of your AND operation, so both Boolean expressions, are already evaluated to true. And true if both sides are true. This is true and that is true. Then the whole thing's true. Right? 2 less than x and x less than 7. Right? It's true if both x is bigger than 2 and x is what? Less than 7. And it's false if either side is false. So if x is not bigger than 2 or if x is not less than 7, then the whole thing evaluates to false. Anyone remember number lines? Yeah, right? I'm going to draw a number line. Right? Here's my number line. Right? I have a 2 and I have a 7, right? This line of code, 2 less than x and x less than 7, means that x must be bigger than what? 2. So x needs to fall somewhere in here. But x also can't be any bigger than what?
7.
Right? So it's going to be true if x falls in that range, and false if x falls in any of the outside range. Right? Including the endpoints, right? Because it's less than, not less than or equal. So
That says x is greater than 2.
right, or it also says 2 less than x. But yeah, x greater than 2. So x is bigger than 2.
Oh, okay.
And x is less than 7. So if I have this, score is greater than 0 and score is less than 10, right? If score is 5, what does it evaluate to? True, okay. Why true? Well, left side, 5 greater than 0. Is 5 bigger than 0?
Hell yeah.
Yes, so I go to the other side. Is 5 less than 10? Perfect. Yes and yes, true and true becomes true. True. Good. What if score is 10?
False.
False, because is 10 bigger than 0?
Yeah.
Yeah? Is 10 less than 10? No. Yes and no becomes false. Okay. So a lot of times we will figure out what they are, we'll put them in these truth tables, and so we'll say true and true is what?
True.
And true and false is
False.
and false and true is
False.
and false and false is
True. It is. It is not?
No, false and false is false.
What?
If any side of the AND operation is false, the whole thing's false. Whether it's one, the other, or both.
Cool. Interesting.
In C++, you can't write string of inequalities, right? You see this in math, right? X is less than y, y is less than c. But really, what are we really saying? X is less than y, and
More than
y is less than
less than.
Z. All right, everyone hear the and in the middle?
Yeah.
And we know how to write ands, right, with those ampersands. I don't know how to write them, you know,
My
with a pen. I know how to type them.
My teacher right now, he can just like
Really well.
Oh, dude, they're like exactly like the keyboard.
Mine are terrible. Mine are terrible. And you would think after all these years that they would be better, but they're not. So, yeah, you do what you can do. So in C++, we write it as x is less than y and what? Y is less than z. Kind of nice we write it like we say it, right? X is less than y and, right, 2 ampersands, and y is less than z. Make sense a little bit? Or is true if either side is true. So and is pretty strict, right? Both sides need to be true, then I'm good. Or says, if one side or the other is true, I'm good, right? Either or, right? Or from either or. So x is less than 2 or x is less than or greater than 7. So it's kind of the opposite of my number line that I had before. We're saying x can be what? That says x is less than 2, right? So it could be anywhere over here. And it says what? Or x could be greater than.
But either one has to meet the condition.
Either one, right? So it has to either be in this range here or this range here to be true. But if it's in the middle range, then it'll be false. So here's score greater than 3 or score less than or equal to 1. If score is 5, is 5 bigger than 3? Yeah. And the nice thing with or is if you say yes, then you're done. Right? I could try it on the other side. Is 5 less than or equal to 1? No. No. Right? But one side said true and one side said false. True or false is true. So long as one side or the other is true, then the whole thing is true. What about score is 1? Is 1 bigger than 3? No. But is 1 less than or equal to 1?
Yes.
Yes. So it evaluates to true. True, because it's one side or the other. What if score is 2? 2 bigger than 3? No. 2 less than or equal to 1?
No.
No. 2 no's make a false. Right? Only when you get 2 no's, right, 2 falses with an or, is the whole thing false. Right, so if you look at that truth table, it looks something like this.
Wait, the only way it can be false is if they're both false?
If they're both false.
Okay.
And the only way that an and to be true is if they're what? Both true. So we take a true or true, and we get true. True. I can write pipes, I just can't write ampersands. True or false becomes
True.
False or true becomes
True.
and false or false becomes false. So the only time that ors are false is when both sides are false.
Are there any cases where two wrongs make a right?
No. Doesn't happen in life, doesn't happen in code. Right? There are things called exclusive ors where 2 rights make a wrong. Because it's exclusive, one or the other, but not both. We don't have to worry about that. And nots are super boring because they just change it. Okay? True becomes false and false becomes true. Right? So I wrote the truth table, right? It's as simple as exclamation point true becomes and exclamation point false becomes.
Oh, here we go. Right? Two wrongs make a right.
Yeah,
That's like if you want something to not be working until the condition's met.
right, or you want to switch it. So in our next game, we're gonna have a gun that has 1 bullet, and so it's a condition. It either has the bullet or not, right? So true or false. And to switch it, you can just not.
What are the answers?
Yeah. Remember what did I say about nots? Don't use them, right? Okay, so why? Let's think about this. This says not score less than 4. Okay? So if score is 5, 5 less than 4 is?
Well, it's not. It's
5 is not less than 4, so that's
Not
false.
makes it true.
But then the not makes it true. If score is 1 less than 4? Yes, then the not makes it false. Okay? What am I really thinking? What am I trying to say here?
Switching the sign, right?
I'm switching the sign, right? What should I have written? I heard score greater than 4. Is that correct? Greater than. Okay, because 4 is allowed as well, right? here you're saying not score less than 4, right? Meaning score has to be at least 4 or more, okay? Both of those things mean the exact same thing. One of them hurts your brain a little bit more than the other. Maybe they both hurt your brain. Maybe you always struggle with greater than and less than, but I'm sorry, but we're gonna have to get real good at it.
How hungry is this alligator?
Not necessarily. You will use them. There are reasons why we have them, but if you can change your not thinking to be right, that positive thinking, then you should do that. Cool. Let me talk about your lab, and then let me talk about. You want me to talk about your coding assignment?
What does it
What
do?
about C and Reader?
Well, that's part of your coding assignment. I'll bring it all in.
Oh, okay.
I'll bring it all together.
I still haven't been able to compile that.
I just want to, I wrote something out, I copied your code. All right, let me talk about the lab real quick. You are partnered up. If you're not partnered up, then, and you want to partner, just grab a partner. But everyone should have grabbed cards, you all should be partnered up. Because I'm going to talk for a while still, so you'll have less time on lab. So if you could have a partner. Question 1, right, I've given you Boolean expressions. And you need to determine the value, right, that it's going to be, which means that the answer is going to be either true or what? False. Except for E and J, I throw in what? Unknown value. Unknown value could be true or it could be false. So then the question is, can you get an answer without knowing that value?
No.
Or do you not know the answer? And if you don't know the answer is going to be unknown. If you think you can figure out the answer without knowing that value, then you could say true or false. Okay. I was going to give you a hint. My hint would be there is unknown is not an answer. They all evaluate something. Okay, that's my hint. They all evaluate something.
Oh, I see.
Yeah, E and J can be evaluated into something.
Scroll. Here we go. Question 2, right? Once again, you're going to determine true or false, right? And I throw in that maybe I mistype things and it could be an error, right? True, false, or error. Right? I can't just give you 50-50. That's too easy, right? Count value is 0. Limits value is 10, right? So you would have to say, does 0 equal 0 and is 10 less than 20? If both of those are true, then the answer is true. Both of those are, either of those is false or both, then the answer is false.
If one expression is an error, would the whole thing be error?
If one expression is an error and it comes first, then it'll be an error. If it comes second, then it will only become an error sometime. We'll talk about that on All right, so D and E, pay close attention to that. 3 has got to be one of my favorite questions of the semester. You probably might not think that, but I really like it. Right? 3 is to kind of take like what you would have written in pseudocode and figure out how do I translate that into a Boolean expression in code, right? And symbols, right? And so let's look at A. A says alpha, which is a variable. All the blue ones are going to be variables. Alpha is greater than 1. How would I write that?
And alpha double equal 1.
Not double equal, but alpha. Right. I told someone to say, you just write alpha is greater than 1. Right? That's how we say it. But right, symbolically, right? Alpha greater than symbol, and then what? 1. Right? A is not so bad. B, though, all of a sudden throws in a wrinkle. B says what? X is odd. And as far as I know, there is no like symbol for odd. Right? It doesn't exist. You can't just make crap up. I mean, I can, but you can't. Right? So the question is, how do you test a variable to see if it's odd or not? Anyone have any ideas? Is X a multiple of 2? And how would you check to see if X is a multiple of 2?
N plus 1 or something like that?
Mod, right? Someone said modulus, so mod. Okay, what would I use mod for? What do I have modded by?
2.
So if I mod something by 2, then the remainder will either be what? 0 or 1, right? Right? Remember when you mod by 2, it's 0 or 1. If I mod by 10, it's 0 through 9. Right? So if I mod something by 2, the remainder is either 0 or 1. The remainder is 0, it went in what? Evenly, which means the number is a even number. If it goes in by 1, then it went in oddly, and so the number is odd. So if you mod something by 2 and that answer equals, then it's odd. Does that make sense a little bit? Yeah. It hurts, but I like it. Let's talk about I and J real quick too. Says I says my char is an uppercase alphabetic character. Okay. All you need to know, right? We've been kind of looking at this. Characters are really just integers behind the scenes, right? And so A alphabetically as a capital character A. Everyone see I have the single quotes. Character A is a number that is smaller than character Z. Okay. You don't even have to know the numbers. You just have to know that character A is smaller than character Z. So we go back to our number line example. Character A comes on this side of the number line, and character Z comes on this side. And you want to make sure that it's any of those characters inside, inclusive of that range. Does that make sense a little bit? And then the other thing to note is character 0, right? Because J says digit, which is of type char, has a value that is indeed a digit. 0 is a digit, right? So character 0 is smaller than character 9. So once again, it's just an inclusive range. You want the lower limit to be character 0, and you want the upper limit to be, right, character 9. So it has to be bigger than 0 and less than or equal to 9. Anyways, your eyes do not deceive you. That was question 3, and the next question is question 5. Question 4 just evaporated. It's gone. Don't worry about it. 5 through 7 says write a line of code, right, to basically practice C and read it, right? Get an int between negative 100 and 100. Get a character that is y or n, upper or lowercase. And get a word that is 6 characters or less, but the user has to enter something. So really you're getting a string that is between 1 and 6. All you need for your answer is just that one line of code for storing it, right? If I teach you how to use C and Reader, then you can test it today too. So that's what we're going to do next. All right. So let's look at that. And then I swear I will stop talking. I have to read this to you. The purpose of it is to learn stuff. That's what that says. And so this assignment, you're making another game. I apologize if you hate games. The first 2 are games. The next 2 assignments are not games. They're like calculators. They're quite boring, actually. So enjoy these before it gets really boring.
Heart rate, whatever.
Right? You have to do stuff. And then your last one will be a game.
I saw Maddie doing one of those.
But she was doing one of the big assignments, yeah. Mine are a little bit different. But
It's a rock, paper, scissors game?
kind of, but it's not rock, paper, scissors. Let's talk about it. So you're gonna make this game called Shootout. And in it, it's like an old Western game. So you have 2 people facing each other, they're gonna quick draw, all right? But at the beginning of the game, neither of them have a bullet, okay? And so neither of them have a bullet, and so every round of the game, the user, right, or both users really, can do one of 3 things. You'll be making the game so you'll have a user, and then the other user will actually be the computer. So you'll play against the computer, much like your first game. In the game, you can either reload, which gets you a bullet. You can shoot if you have already reloaded, good. Or you can block, because you're super fast and you can block bullets.
What?
Okay?
So
So what?
then what the beta Oregon Trail looked like.
Yeah, right? Exactly what it was.
Oh my god.
If you can change the theme if you're really against guns and bullets, I'm okay with that. I always switch the theme every semester. Every semester is a shootout. But it's nice, whatever theme you pick, it's always nice to have a little flavorful text, right? Get your character, right, your user into the console text game that you are writing. Not just, hey, enter something and let's do something. Right? Okay, so let's talk about this. 3 choices, agreed? Every round you have 3 choices, except you don't really have 3 choices. Why not?
You have to reload first.
You have to reload first. So the first round, can you shoot?
No.
So how many choices do you really have?
1.
Well, you could just block.
Well, you can't block if they're not gonna
You
shoot.
can always block. Block is always a choice. Right? You can just, to not lose the game, you can just cower in the corner the whole game.
And
You will
block.
never lose.
Or just
You'll
make
never
it.
win.
Or just make it. You can only press block like
You'll never
twice.
lose. So you can always block, which means that sometimes you can reload if you don't have a bullet. Did I mention your gun only holds one bullet?
Yep.
So you can only reload once, and then the next turn you can only what? Shoot or block. So while there are 3 choices at any given time, you can only make one of 2. Question in the back?
I was going to ask if we could do something like put block on a cooldown timer to speed up the pace of the game.
Well, there's no it's all text-based, so if you're gonna do a cooldown timer, you'll have to do it based on your round.
Yeah.
But no. I mean, yeah, you could. If you really wanted to implement that, that would be okay. Wait till we get to the add extra to the game.
Okay.
I want to just talk about the base game. When the game starts, both pistols are unloaded, so you probably want to reload at the beginning. Just saying. Because the computer also doesn't have a bullet, so I probably want to block. Games have a quick synopsis of what the heck it is that you're trying to do, right? And then basically until the game is over, so it's going to be a loop, and I'm going to give you the loop. So until the game is over, we're going to keep doing the exact same thing over and over and over again. Okay? Until the game is over, this is what it should look like. User gets an option to either block, reload, or shoot, right? But really only block or shoot or block and reload, right? Depending on the state of the game, basically what's happening in the game. All right, so the gun is loaded, don't allow a user to reload. The gun is empty, don't allow a user to shoot. We'll learn kind of how to make those choices. And then because you're playing a computer, you're going to have to generate the computer's choice in code, right? The very simple AI that we're going to give the computer is that if it knows that it's unloaded and the user's gun's unloaded, then it's going to reload. It's not going to randomly choose block. But after that, once it knows that either the user has a bullet or it has a bullet, it will randomly choose block or shoot or block or reload. Does that make sense? Which means what are we going to use to randomly choose it? SRAN, right? And then ran mod something, right? You have the time in the SRAN, right? Remember, you're at any time the computer can do one of 2 choices, so you're going to mod it by how much? 2. Right, mod it by 2. That's what that says, right? So every round, right, the user is going to choose to do something, and the computer is going to choose to do something. So at the end of that round, you have to handle the outcomes, and we'll go over the outcomes in detail next week. But I just want to kind of talk about it, right? Handle the outcomes, right? If there's a winner, right, say, hey, you win or you lose, right, and then end the game, right? How do you win? You shoot and the other person reloads. The only way to win is if you shoot and the other person reloads. Right? The only way for you to lose is to what? Reload while the other person is shooting. Okay? Now, hopefully someone's good at math. If I have 3 choices and the computer has 3 choices, how many outcomes?
9.
9. Good. Don't say 6. There's 9 outcomes. Of the 9 outcomes, only 2 of them in the game. Does that make sense? So it's a pretty boring game because most of the time you don't win or lose. All right, so there's 7 outcomes that other stuff happens, such as if you reload and the computer blocks, or if you reload and the computer reloads, right? You don't lose. Something changes though, right? Your gun's loaded and you have to kind of figure out how to store that in your program. And it will keep going until someone wants
You could put the computer like on a switch so it can erratically choose true or false and reload or not.
Yeah. All right. Well, we're just gonna do it with the random.
What if you both shoot? Like, do
Good
you
question.
both
So, does it say that somewhere?
I read it somewhere. It said that that's a
No, I think
draw.
I'll say it later. If you both shoot, it's a draw.
Oh, okay.
Now the draw, you can choose that to be end game, or you can be like, oh wow, the bullets magically hit each other in the air, and then you get neither of you are dead, and you keep going. Right?
You could also put it
you
like
could
if
choose
you
which
draw
one.
3 times, computer wins.
Yeah, right. But at the end of each game, right? So the game's made up of games, and each game is made up of rounds. Does that make sense? So there's this kind of outside loop of code that we keep doing over and over and over again. That's do you want to play again? Okay, that only happens when a game ends. You shoot, they reload, or they shoot, you reload. Everyone kind of good with that? All right, so at the end of each game, you're presented with, do you want to play again? I wrote that code for you, so I'll show it to you here in a minute. From the last one, you're like, I didn't know how to do loops. And by the end of this, you still won't know how to do loops. Well, actually, by the end of it, you will.
I mean, if you take 5 minutes on Google, you'll learn quite a bit.
Loops
C++.com, like spell out it.
Let's see, extra requirements. Computer's going to select their choice as an integer, right, and not reveal the selection, right? So they're going to get it via the random number generator. I've talked a lot about there's 3 choices, but at any given time, there's really only what? 2 choices. The player will select their choice via a character. I want to see that via a character, right? Via CN reader, right? So reader dot read char. Notice their choices are going to be what? R for reload, B for block, and S for shoot, right? So in double quotes, right, for read char, you put R, B, X. Make sense? You want some hints? Give you some small ones that will be laid out, and then I'll give you some more stuff next week. Make blocking the middle choice for the computer, because the computer can always what? Block. So really, when you're setting it up, I lost my pen. I do that a lot. When you're setting it up, you can think of the fact that the computer's choices are going to be numbers, agreed? But you can think of those numbers as characters or, right, really as something, right? So if we think that the computer can reload and block or shoot, then you can think of reload as being like 1, block as being 2, and shoot as being 3. Does that make sense? So when you randomly generate a number, you'll either generate 1 or 2, or you'll generate what? 2 or 3. Okay. You can get a range of numbers by modding it by 2. And you can move those numbers by what? Adding to it. Right. Remember we got 0 through 9 in the number guessing game? And then we moved it by +1, 1 through 10. And then before the user chooses an option, you should tell the user like where they're at in the game, right? Your gun's unloaded, the computer's gun is loaded, you're cowering in fear. What do you want to do? Right? Just let the user know the state, we call it the state of the game, right? Because they don't really know unless they scroll up and try to figure out like what happened. Nice to give your user an idea of what the heck's happening in the game. Make sense? And then to the thing that we've been waiting for, right? I gave you a starter file. You might not have it yet on Cloud 9. You might just have assignments 1 folder. That's probably true. So in the terminal, which is bash, it says bash is one of your tabs. You need to write these 3 lines. CD space tilde / workspace, enter. Get remote add class, this thing, enter. Get tool class master and enter. If you do that, you will get assignment 2. All right, all the code for assignment 2. You'll also magically get the runner that is C++ assignment, which is what you'll have to use in order to compile your assignment. Does that make a little bit of sense? So I would do this before you leave today. That way you know that you just have it. Or if you mistype something, I can help you fix it.
So right after the $, you type CD tilde, enter.
CD space tilde / workspace. Although you're probably already in workspace. And then get remote, and then get. Yeah, there's a space. There's a space in there. Just hit Control C.
It says command not found.
Means you misspelled something or you
Yeah.
space.
Right. If you do this and something pops up, the way you get out of that pop is Control X. You'll see on the bottom left it has like a caret X. Caret for control for control.
But why is it wanting to do it?
Anyone have any questions? This assignment is much bigger. Hopefully you're realizing this. The assignment's much bigger than the number guessing one. Which is why instead of having 1 week to do it, you have like 3.5 weeks to do it. You had 4, but I didn't talk about it.
Should we create our file we're going to be making the game in?
No, so I've created the file for you. I'm going to show it here in a second.
Okay, so
So doing these lines will give you an assignments 2 folder, and inside of the assignments 2 folder will be like all the starter code. And I'll be glad in lab time to come around and help whoever out with that. But let me show you that file. Right. So I have an assignments folder, I have an assignments 2 folder, and I have an assignments 2.cpp folder, or file. Right, it has all this. You should probably change all the stuff on top. But it already has the include for CN Reader. Right? I already set up CN Reader, and I have a loop. That loop will run continuously. It says do says run the code, and it says, would you like to play again, yes or no? And depending on what the user types, if they say yes, it'll loop again. If they say no, then it won't loop again.
When I tried to pull from the server for this project, it gave me a message. Merge branch master of github.com PI Spring 18. Please enter a commit message to explain why this merge is necessary, especially if it merges an updated upstream into a topic branch.
Does it have a caret X on the bottom?
The caret X?
Yeah, hit Control X.
Okay. Save modified buffer.
Yeah. If you want, although Control X will do that.
Lectures, lecture 4, increment, decrement, CPP 100%. Wait, what did I just do?
You got all the files that you need.
Okay, I was making sure I didn't like overwrite anything.
No, you'll never override anything. That's not supposed to be overwritten. This actually runs, so I can run this. Alright. Notice I get undefined reference, because I need to change my runner to be what? C++ assignments. So if I run it again, it's an amazing program, and it says, would you like to play again? And if I say yes, what's it going to say? Would you like to play again? If I say yes, it says, would you play again? If I say no, then what happens? In programming. Your code doesn't have this. I added this thing called clear screen. Right, clear screen literally does what? It clears the screen, so you may want to add that so you don't just keep getting text over and over and over and over.
So that's all this stuff.
So anytime you can type clear screen, capital C, capital S, open close paren, semicolon, and it will clear the screen. So I didn't have that in there, and I ran it. Right? It's going to ask me, do I want to play again? I say yes. Notice, right, the text keeps going on top of each other.
So we don't have assignments.
You will eventually.
Oh wait, yeah, I do.
You should have it now.
I lied.
You did it right. So here I bring clear screen in, and you'll notice that when I don't want to play again, if I say yes, it actually clears the screen. That can be useful. Like, they're only between rounds, it's nice to clear the screen. Because at the beginning of every round, you're going to tell the user what's happening, right? So clear the old round text away, bring the new round text up.
If we switch to like a for loop, are you okay with that?
If you want to, but I don't really want you to do a for loop with a break.
Okay.
That's bad practice.
Okay.
So if that's what you want to do, don't do that.
That's what I was thinking, but
Yeah.
I won't.
Question in that?
Lectures, lecture 5, CN Reader example, CPP has been deleted or is no longer available. Do you wish to keep the file open in the editor?
No. What happened is that when you pull down all your new files, I had made a mistake. All of your lectures were like lecture space 1, lecture space 2. Anyone ever try to run the examples and it didn't work?
Yeah, it didn't
Right?
work.
It didn't work. Yeah, that's my fault, my bad. Right? It doesn't like, Cloud9 doesn't like spaces. So I changed all the spaces to underscores. So when you pull down all the files, it'll change all your folder names to have underscores magically. Which means if you had any files open from the spaced folders, then you'll get that weird.
Hey, you did it. Yeah.
Pretty cool, right? It's like magic. Right? It's kind of cool. You guys are going to be magicians too, right? It's going to happen. All right, overall questions before we get into the lab, now that I've talked for an hour and a half. Much too long. I apologize, today's lab's like a math book, right? Because there's only 6 questions, but you know, some of the questions are like A through Z. Only A through L, right? So it's not really 6 questions. And make sure you sign the sign sheet. I'll have to sign it.
Well, I think it's somewhere like so I'm just writing here. Value, you're probably somewhere around 30. So
No, God. If you mess up once, you have to start all over, huh?
Line 19 is not right, because that's what it's why.
you're asking
Any of those lines that were in the assignment, they must. So this is virtually that's fine. Not bad. Yeah, that's why I could just like that's okay. I'll get it. Well, it does it automatically. If you hadn't changed it, because they're kind of like they're mirrors, so then since mine changed, we'll just drop down. Because yours changed, it won't like force overwrites down, which is a good thing. Right, so but it's like, okay, well, I have this, this, which is like all right, sign sheet's going around. Conflict, so we need to do like
Thank you.
oh, wait.
and it's less than those conditions are. For some reason, I keep writing, it kept reading limit as 20 because it's using limit and 20 twice. So I had to read out. But yeah, it's a goal. So this just makes it
I'm not positive on that.
yeah. So like that's 0. So but this condition is met.
Yeah, but it says something about if you have an error in the first expression, then it makes it.
Oh, then that's different.
God, why?
Same thing again.
When I think it actually the switch, it would be okay. But
Oh, is this the one?
So you're asking about
You brought it?
try to put the expression.
I'm always on here.
So I'm pretty sure this is not faulty. Yeah, it's like equal like I want to say it's x mod because that'll always give you a 1 or a 0. it'll go in evenly at 0, or it will.
So, yes, it's like X punch. Yeah.
I'm pretty sure that's how you do it.
Yeah, I looked it up.
I don't know. It's either that way or just that. It's either the whole thing or just that.
Yeah, like I'm also trying to have
So answer mod 2 see out.
So exclusively you don't do it.
That's what that's saying. So basically that's just a different, that's just really backwards from what I thought.
that's why
But the way he worded it is that way. Because, yeah, so it's gonna do that.
But 0 is an even number. False. That's true.
So it's
Well, you could just do right on those.
I think it would be 0 mono.
Yeah, and then like, you can do stuff.
Did you get your repository to work?
I think so.
On the bash.
I think I'm working.
Yeah, you got it.
Yeah.
See, I need it.
I did the parentheses.
It's, so it's saying that's, you're gonna wanna do.
The bash. Oh, should I just close it?
In my eyes, you get that.
Saying X and Y.
Oh, wait, you know what? Only zero or one.
And then, so this, the same, that first part, and then on the other side it's that one. No, like, get rid of that entirely, and then copy this one over, and then replace it with that. So you like,
You see what I'm saying?
Yeah,
Yeah, I'm giving it.
Yeah, but wanting to know what either way.
Yes.
Like technically,
We won't be able to do it.
Oh, that was easy.
you see how like basically you would just put an false and then give another condition. So then you would have to. So it's like technically it's just put the right. You would know false.
Like the parentheses don't really do anything, they just make it clear.
No, like if statement. That's So this is saying if this is going on, do this. So this will
True and unknown, it's true and
So that's why technically you're worried about it. The next one. Yeah, I mean, I don't know. I'm just saying, like, technically.
Yeah, I think
I could be super wrong, but you're not ever really gonna be. Right. Like that's not. Do this while master class?
Yeah, I think it's.
Those are your conditions.
Last master.
How you doing? You got it?
Well, number 3 is confusing as hell.
Oh, okay.
Yeah, so
For like B, C, and D, it's asking if it's odd, so you gotta mod it with 2 and see if it's equal to 1.
X modulo 2 is equal 1 and pick up.
Yeah,
And if it's false, then it's false. So if it modulos 2, then it doesn't output 1, then it's false. And it's
yeah, then it's even.
Then E is at least one of the X or Y is non-negative.
Yeah, so it's just got to be greater or equal to 0. At least 1, so you use the or.
And it's saying or.
Yeah.
T is between 3.2 and 3.3. Is between 3. Oh yeah, it's basically like writing
you gotta like
it.
split it up. And then one's inclusive, and then the first one's not inclusive. And then the other 2 are kind of like with characters instead of, it's like the same thing but in between characters, I guess.
Okay, I see this. Basically, it's like writing it out like a math problem, but you have to use and because it's using it separately.
Yeah.
Alrighty then.
Yeah, kind of like Algebra 1.
Yeah.
Okay.
Or what is that, interim algebra or whatever. Well, anyways, I'm out here.
Alright.
Okay.
Mine is giving me this.
Okay.
Hey, have a good one, man.
Alright, later.
So it's like greater than 1 is inclusive. So if it's then it has to be greater than, it cannot include.
So you're saying it's actually like greater than or greater than.
That's correct.
So it's like, so T is between now.
Wait, is that like the outline?
Okay, so for G, yeah, it's not like the start. It's like this, not like the starter code that Okay, so this one is, yeah, we have some questions over here. No questions, we're in line.
You can make X in line.
Oh, I guess that is.
Do you remember this one where he did the like
And then,
line?
yeah, and then.
That's what you got.
So is this right?
I'm pretty sure it's just.
X, did I do that right?
But it's not 0 mod 2, it'd be X.
Same.
I had it. So you're gonna take the variable, you're gonna multiply by 2, and does that equal 0 or 1?
Yeah, behind the.
So say X double equals X mod 2, say X mod 2 double equals.
How do you do this one? D.
So 1 equals.
No, D, the second
No,
to
right
last
the other way
one.
back.
That's number 2.
Does 1.
Limit divided by count is greater than 7.
Modify by 2. But X, right, X is. So this will evaluate to true when X is odd.
Because count is 0. It's 10, so it just gives 10 over 0.
Oh, okay, and it's so it's, okay. 0 is greater than 7.
Yes.
Same
So
thing,
then
but
it's
I
not.
mean, at least one of X or Y
So
is
then
not.
say
So either,
So that one's false too. No, that one's false. Oh yeah, it's true. So they're both. So that one's true, and then this one's false.
Yeah.
Okay, I got that one.
You can say greater than 0. Either way.
I like that.
Or, right, it's either right, or Y is greater than.
B is 3B.
So as long as one or the other is not negative, then you.
So let's skip all
that's
this.
You skip the list.
And then if it's hard.
Yeah.
This is that lookup number line tree.
Well, no, you're just gonna use hands. You could put parentheses if you want. Right, it's between that, so T has to be bigger than 3.2 and it has to be less.
Right, okay. Got it, thank you, yeah.
T
You have to go right.
Okay. So non-negative would just be 0 and 9. Greater than equal to 0. X is greater than or equal to 0. Anyway. That's 1, right? It's 1 of, right? So it's an either or.
Hey, I did the 3B and X. How would you write that? How would you define that?
For what number?
3B.
So you're gonna set your, you have, this is the double equal form, right? So you have,
So I and
so
J
you're gonna
are just
do,
like
like, if you ever mod to something, you're either gonna get back to 1 or 0, right? If it's 0,
Here we have 2
put it in 1, because 2 can go in, you know what 2 is.
Yeah.
So if you do 1A, exactly.
You're correct.
Right, whatever.
Imagine that being
variable is mod 2,
is smaller.
it'll be true whatever.
So just like 3, 1, 2,
Double equal to smaller than mod 2.
A,
But it's variable.
single quote, smaller than shares to C, and then to the last one.
I'm saying variable because you can have whatever you
Anything's
name.
for X.
Right, but he's asking us, he gave us.
We can use the same,
So 1 is equal,
Yeah, but
double equal to
but it's the same
X
format.
mod 2 or
Yeah.
the X mod 2?
It'd be, it's X mod.
Okay.
Okay, sorry. So one of these. Oh, this one just means inclusion, so that's here, yeah. Sorry, I was. Sorry, here.
So that when you include skin reader, those files have to be in the same location that your file is. So you have lab file, right? File system wise, it's on the same directory. Right there. And then we include. So if you wanted to know, right, so there's a bunch of time. That are seen in your example.
Isn't this where you do like the?
So you need to put those 2 files and lab5 into its own folder. So you don't want to add our C++.
So just copy all of that.
Yeah, no, organize stuff.
Yeah.
So yeah, you got
Yeah, you're right.
What is organized? Right afterwards.
No, but this is the line, this, that inclusive, that is what it is.
Yes.